And then let me get back to the meat, and I'm going to present my screen here.
If you remember Lindsay, this is Lindsay's. And Lindsay is way smarter than Alice.
Lindsay? Which Lindsay?
Lindsay Todd.
Ah, yeah. How'd you get her stuff?
Don't worry about it.
I wrote Lindsay a recommendation letter. I'm going to take it back now. She didn't give you her stuff.
I have her whole binder.
Nice. Not many things change. If it's working, I ain't changing it. All right. Can you guys see my screen again? Awesome. All right. Let me just hide that right now and go. Okay. All right. So oxidation means that a molecule is losing protons and electrons. And that's the symbols for protons. Remember, protons have a positive charge, electrons have a negative charge. Okay. And by the way, does it make sense? Hydrogen, a hydrogen atom is 1 on the periodic table. So that means a hydrogen atom is just 1 proton and it's 1 electron. Okay. So if a molecule loses an H, like this, glucose, see that? That's an H, that's a hydrogen. Glucose just lost a hydrogen and electron. Glucose just got oxidized. Okay. Now, the hydrogen, the protons, the electrons, they have to go onto something. They're on my hand now. Does it make sense? My hand got reduced. Okay. So these reactions always happen. If oxidation happens, then something else is getting reduced because they have to go somewhere. So RIG means reduction is gaining. So I would say glucose got oxidized. My hand got reduced. Okay, because it got the proton and the electron. Okay. All right. So keeping those things in mind, and you will have to be able to explain using the words oxidation, reduction, some of these steps. Okay. So let's go back to these. By the way, these all have names. You don't have to know their names. And we are just going to call them. You're going to see every time I'm talking about like these molecules that are involved in these steps, you can just call them the intermediates. The intermediate molecules. It's kind of like, okay, they're important, but they're not really important enough for us to know the names. But they're involved. We're going to be focusing more on, these molecules that we start with, like glucose, and then the molecules we end with. Those are kind of the important things. These other ones, we just call them the intermediates. Okay, they're involved. They're in the middle here. Okay. So what's going to happen at this step is there is an oxidation reduction happen. So what that means is this molecule is going to lose, or you can say donate, it doesn't matter. So let's put donate, a proton and an electron. So we're saying that that intermediate is oxidized. That molecule is oxidized, which means that it's releasing a proton electron and it has to put it on another molecule. And here comes the bus that it's going to load up. So this molecule here, NAD+, is called a coenzyme. And how you make it is from vitamins. So you ever heard like, oh, take your vitamins and you'll have more energy? Well, energy is about making ATP. And if you don't take certain vitamins, you don't have these molecules ready to go in the concentration you need. So you suck at making ATP and you are then sluggish because you don't make ATP very well. So that's why vitamins are important. So NAD+ comes from the vitamins that you guys consume in your food, right? Well, whenever it gets those protons and electrons, we say NAD+ is reduced. Okay. Maybe to help you think about this is like, when someone gets on the bus sinks down a little bit, right? It gets reduced down a little bit because it just gets heavier, right? So when you put people on a bus, the bus gets reduced. So when you put protons and electrons on the bus gets reduced, okay? And now it's not NAD+ anymore, it's NADH. Okay? How am I doing, Vincent? Does this look exactly like what Lindsay provided to you? Have I skipped anything? Am I doing all right? Okay, good. I've only done this a million times in my lifetime, so hopefully don't forget anything, okay? All right, now what this molecule also happens. So when this is happening, there's a lot going on in this step. A phosphate, another phosphate gets added to it. Okay, so we still had this phosphate over here. So it's still on there, but the enzyme that does this step also can grab a phosphate that's in the cytoplasm and just stick it on there because there's phosphates everywhere. Okay, and I still got my carbon atoms. These are just carbon atoms. That's what I'm putting there, C for carbon. Okay, all right, same thing happens to this intermediate. Okay, so I'm going to show like off comes protons and electrons. They have to go onto this coenzyme. This is like the bus. And now that bus is NADH. Again, you say this intermediate of glucose. So technically this is still glucose. It's just half of it. This intermediate from glucose, or you can even just say glucose is getting oxidized in glycolysis. NAD plus is being reduced to NADH. Don't say NADH is getting reduced because that means I have an NADH and we're putting more protons and H's on them. And we can't because it can't hold anymore, okay? And then also, again, a phosphate gets added. And so now I have this 3-carbon molecule. It's got 2 phosphates on it.
I have a question.
Sure.
So NAD plus turns into NADH.
Yep.
So if it is already positive charged by 1, wouldn't adding a hydrogen and adding a single electron still balance out?
Yes, and that's why it actually gets 2 electrons, but I don't diagram that because it gets too bundled. But I'm going to show you another diagram that shows it's actually 2 electrons get pulled off and 1 proton. So then it's all balanced out and there's no charge on the NADH. Smarty pants. Okay, so let's keep going. Now let's think about this. We're trying to make ATP, right? How many have we made? 0. So let's start to make some ATP, okay? Now, again, every step there's an enzyme that does this. And this next step, I'm going to go ahead and draw an enzyme to help you remember something key that they almost always ask on the AP test, okay? So this is an enzyme. So I'm going to put just an abbreviation there. So here's the enzyme, okay? Now, does this make sense? This is the active site of the enzyme, and this molecule is going to go into the active site. Does it make sense that I can say, oh, this molecule is the substrate? Remember substrates? Okay, on the enzyme posters, just making sure, okay? So this enzyme can take in the substrate, and it also takes in ADP. Okay, takes in ADP. And it positions those two together where this phosphate comes off of the substrate and hooks on to the ADP. So now how many phosphates would I have on there? 3. Does it make sense? Because ADP is 2 phosphates. You add another one. Now I have ATP. Yay, we made 1 molecule of ATP. And let's just see if this makes sense. This intermediate is going to look exactly the same. It just is going to be missing that phosphate. It's still going to have the phosphate on this side, but the phosphate on the other side is gone. Okay? All right, now the reason why I went ahead and I draw the enzyme is because we can make ATP 2 ways. So we can make ATP where an enzyme just makes it for us, and it takes the phosphate off of the substrate and slaps it on ADP, bam, ATP. Or we're going to see in the mitochondria, ATP is actually made like energy is made at a dam. I know it's crazy to think, but you know, a dam, like water runs through and it spins a turbine and you can generate electricity. That's actually how ATP is made in the mitochondria. Like something flows and spins a protein, and the protein then can make ATP. It's kind of crazy. But Anyway, when an enzyme is being used to transfer a phosphate off of a substrate onto ADP, this is called, and it's a word expect to know, substrate. That's why I made it a big deal about making sure you know that, oh, this would be the substrate. It's called substrate level phosphorylation. Okay, so it's called substrate level phosphorylation. And if I say, okay, substrate level phosphorylation happens in glycolysis, it just simply means there's an enzyme that can make ATP. It can take a substrate, pull off a phosphate from the substrate, and put it on ADP, and now I have ATP. Okay, so that's how glycolysis makes ATP, is through a process called substrate level phosphorylation. Okay, the same thing happens over here. And I'm not going to put the enzyme, but just know it gets too crowded when I do that. In comes ADP. This phosphate gets pulled off, gets added. And so now I have ATP. And this molecule now just is missing that phosphorus, but it still has this phosphate group on it. Okay. So we made 2 ATP. And then does it make sense? We can still make 2 more ATP. Do we still have 2 phosphates? Yeah. So then another enzyme grabs onto ADP, turns it into ATP. And now I'm just left with a 3-carbon molecule. I'm going to show the same thing over here. So again, that phosphate comes off of this intermediate onto ADP. Remember, D means 2, di, and now it's triphosphate, ATP. Okay, and then this molecule, this looks like that now. Okay, so I want to show you how much of the glucose has actually, how many atoms have actually been removed, just to make sure that this makes sense. All we're doing is breaking down glucose. We're taking off an atom and another atom and another atom and another atom. Okay, so let's see if you kind of understand some things. Okay, there's 12 H's to remove. Does that make sense? There's 12 H's to remove. How many have been taken off in glycolysis? 2. That's it. Look at what's left of my molecule. Like this H got removed and this H got removed. Look at all, oh, I better put an H back on here. Look at, like, glucose is still mostly there. We still have a lot of processing to do, okay? We still have a lot of steps to continue to break down this molecule bit by bit to get energy from it, okay? So does it make sense where glucose lost? It had 12 H's. It lost 1 here. Does that make sense? And it lost another H off of this intermediate to go here. Okay, we've only lost 2 H's. We have 10 more to go, right? Have we lost any carbon atoms? Have we pulled off any carbon atoms and shipped them off on something else? No, we still have 6 of them there, okay? So they're still here, okay? Now, a couple little bits of information, and let's grab our color pencil, okay? So I'm going to talk about like these coenzymes, NAD+. I like to call them the buses, okay? Because there's some kind of it's a good relation to what buses do. They pick up things, they get loaded up, they get reduced, they get closer to the ground the more you put on them, right? And then buses can go somewhere and unload. And that is what we are eventually going to see happen here with the NADH. It's going to take those protons and electrons that it picked up, and it's actually going to drop them off somewhere else. So it's literally kind of like a bus. So since buses are yellow, let's kind of color around our NADHs here. Okay, so you need to be able to tell me that in glycolysis, 2 NADHs are produced. When I think of a color for energy, like I usually kind of think of like a red, or I already used yellow for my buses, so I'm going to use red for energy. Now, in glycolysis, you need to be able to tell me that 4 ATP can be made from just one glucose molecule, because we only sent one glucose molecule through these series of reactions here. Again, adding the color really kind of helps you remember. Like you might be like, okay, wait, I remember on this side of my poster, there was 4 red circles. 4 ATP are made in glycolysis. Okay. And then, by the way, these 2 molecules, you know, basically, if I took this and broke it in half, I would have those 2 molecules. Okay. And they have a name, and you need to know that name. These are called pyruvates. And you can see I have 2 pyruvates. And that's kind of a big deal to know that. Okay. In science, we can give everything like 2 names. Remember, to confuse you all. I can also call it pyruvic acid. I have 2 molecules of pyruvic acid, or I can say I have 2 pyruvates. Okay. All right. And then I am going to take my green just to kind of emphasize something here. And I'm going to go back. I'm just going to make my glucose green. You don't have to make all of these, but I just want you to realize that these aren't 2 different really molecules. This molecule is glucose just later on in time. You just take the glucose, and the glucose now has like, it looks like it's wearing like bunny or squiggly funny ears or whatever. Okay. Googly ears, whatever. Okay. And then eventually I still have most of my glucose. It's down here. It's just in pieces now. Okay. All right. I feel like I'm missing something. There was something else I was trying to point out here. All right. I'll figure out what that is here in a little bit. Okay. I want you to take 4.2. And we're going to go look at a diagram that probably would have been super confusing. And even after you listen to lecture 2, you still wouldn't be able to read this diagram. But now that I've kind of drawn the poster with you, this diagram hopefully is going to make sense. Okay. There's a million ways I can diagram like this glycolysis. We just did on our poster, but we can draw these molecules so many different ways. You need to recognize key things so that you could look at something like this on the AP test and be like, oh, this is glycolysis. Okay, this is about making ATP, right? So a few things. I just want you to take a minute. I just want you to kind of look here and see if this makes sense, because it should resemble some of the things that we did on our poster. Okay, so just take a second to study that diagram. And then Vince, do you see how the 2 electrons, do you see how there's 2 electrons? And that's why the NADH doesn't have a charge on it. Because the NADH actually gets 1 H, a proton. It gets and that's a proton and electron, and then it gets an additional electron to cancel out that positive. That's already there. Okay. All right, let's see if you guys can answer questions about glycolysis now. Again, this is the big idea. This is the stuff that I do need you to be able to know and do, okay? So first of all, you need to be able to look at this process and know what this process is called. What's this process called? This is glycolysis. We wrote that. We did write that, didn't we? Yeah. Okay, so this is glycolysis. That's number 5. You need to be able to tell me that glycolysis makes how many ATP? Good job. 4 red, right? You need to be able to tell me that. And you can see them being made here. Okay, you can see them being made here. You also have to be able to tell me that, you can see it right here, because they say ATP got consumed. So if you see negative 2 ATP, that means it got used. Okay, so you have to be able to tell me that 2 ATPs got used. And so that's why, like when you watch videos or whatever, they'll say glycolysis gives you a net of 2 ATP. Does that make sense? You actually made 4, but you had to use 2 to start. So you're really only getting 2 out of this process. But that's not a bad trade-off, right? I'll make you guys that deal. I will give you $2. You give me 4, right? It's not bad, right? So you use 2 ATP, but hey, you got 4. So, I mean, you're making something headway there. Number 8, why does the hexagon for glucose up here, why does it have C6 in it? Why does it have the symbol C6 in it? Because glucose has 6 carbon atoms. I've got them here. They're the black ones. Those are 6 carbon atoms that make up the backbone of glucose. Okay. So now we need to talk about the oxidation reduction stuff. Get this down. Because again, another way I can describe what's happening in respiration is I can say the making of ATP is a series of oxidation and reduction reactions, which means from glucose, we're going to oxidize it a lot. We're going to take this one off, this one off, this one off, this one off, this one off. And we just do it kind of step by step. Okay, so number 9 says, in the circle, an intermediate of glucose is being oxidized. Okay, draw an arrow to the molecule that's getting oxidized. Let's see if you can do that. So in this circle, I mean, I'm showing you some molecules there. Which molecule is being oxidized and which molecule is what 11 is saying is getting reduced. Okay, so oil, oxidation is losing. So do you see how this intermediate that says C3 on it, that has a phosphate group on it, by the way. See how we do those phosphate groups? It's got those little circles. Okay, so this molecule is the one that is losing the proton. Here's the proton and the electrons. So this molecule is being oxidized. Okay, and so is this one. I mean, this one too, because there's 2 of them, remember. They're getting oxidized. All right, and so you can answer number 10. What is happening if a molecule is getting oxidized? So that means that it is donating or it is losing protons and electrons, okay? Moving on to number 11, put a star next to the molecule that's being reduced. So that's the bus, because it's going to get those things. So here's a bus that's going to, so NAD plus is going to get reduced. There's also another one over here. NAD plus gets reduced. And what does it mean if it's getting reduced? It means that it is accepting H's and E's, protons and electrons. Okay. If I ask you to identify that molecule, can you do it? You see how it says C3? 3 carbon atoms. Okay. So those 2, we're at the end of glycolysis. Those are the 2 molecules of pyruvates, or you can say pyruvic acid. I'm going to show you in a second what happens to it. So here's my 2 pyruvic acids. I still got a long ways to go to break down this glucose, don't I? Okay. So we're going to ship it off and we're going to do some more to it. We're going to oxidize it even more. All right, number 13. At the end of glycolysis, how many carbon atoms have been removed? Does that make sense? They're all 6 still there. Haven't taken off a C and removed it. How can you tell? It's because we started with 6 and we still have 6, 3 in each pyruvate molecules. That's why it says C3. Okay. Okay, and by the way, you can always tell if a carbon atom gets removed, because if a carbon atom gets removed, we will get CO2 produced. And I haven't written once CO2 in glycolysis. So no CO2 is made at all in glycolysis. All right, step number 2. So we're going to take this pyruvate and we're going to prep it. we're going to alter it a little bit. So that's why this is going to be called the prep reactions. Now, watch I need you to draw this a certain way because I've got to save room, okay? So I'm going to take like this pyruvate and I'm going to like put it in the mitochondria here. And I'm going to end up like writing some stuff here. I'm going to take this other pyruvate and I'm going to have it go in there and hopefully this is going to work. Okay. All right, so let's go ahead and show now my pyruvate was been sent to the mitochondria, and I'm just going to focus on one at a time. Yeah, there's two of them, but let's just draw it out for one, okay? So here I have my pyruvate, and we're going to prep it. So this is why it's called the prep reactions, and there's only two of them. Thank God, right? The other one just had 10. Glycolysis has 10 steps. 10 steps, 10 enzymes. Prep reaction, it's like 2 little steps. Okay, so here's where we're first going to make some CO2 because we know CO2 is a product, right? So there's an enzyme, and what it does is it takes off that carbon, and carbon combines with oxygen, and we just made CO2. 1 carbon here. Now we have 1 carbon just on this carbon's just in a different molecule now. So let's think about what do you think my next molecule is going to look like? Does that make sense? And it has a new name, and you need to know the name of this. This molecule is called acetyl. It's acetyl coenzyme A. Okay, and coenzymes are molecules that are derivatives of vitamins. So there's actually another little part that's the acetyl group that gets put on the 2 carbons here. You don't have to know that though. But you can also abbreviate it just acetyl-CoA, acetyl coenzyme A. So just for short, you can just call it acetyl-CoA, but it's coenzyme in case you want to know. All right, and we still got 10 H's to remove. People, we better get going. So even in this step, pyruvate gets oxidized. So I'm just going to kind of put oxy next to pyruvate because it's going to get oxidized. So what that means is off goes some protons, a proton and a couple electrons. Guess what we're going to put them on? The bus. Do you remember the bus? NAD+. Okay. Now it's not NAD+ anymore. It's NADH. So you need to be able to tell me the prep reaction. We oxidize an intermediate again, which means we're pulling off another H. Sweet. Now we have 9 more to go. We have 12 total, right? Carbon atom is removed. Cool. Now we have 5 more to go. And we make this molecule, which is called acetyl coenzyme A. Now, that happens to this one again. Lots of times in books, like in textbooks, they only show what's happening to one of them, and it gets confusing to students. I like to go ahead and draw, hey, don't forget, there's another one that does that, and keep some space here. So again, you have this other pyruvate comes in because there's 2 of them. Okay. An enzyme attaches an acetyl group and takes off a carbon atom. And that will form CO2. We also pull off a hydrogen atom from basically glucose. And now we have NAD+. Sorry, NADH. Okay. So we just made 2 CO2s, right? When we're done though, we're going to pull off, we're going to make, so we have 4 more. And if it doesn't make sense that we still have 4 carbon atoms in this process. All right, so we got 4 more. Okay. We're going to stop with step 2, but before you go, I want to show you something real quick. So now you can I said, this is page 1. I'm going to look down here. I have no idea how they're going to diagram these. This is a super short diagram. Look at what they did here. They put 10 steps in that little bitty diagram. So number 2 says, identify the 2 metabolic processes. Metabolic means that we're breaking down molecules or we're building molecules. That's metabolism, okay? And how fast you do that is your metabolic rate. You see how we start with glucose? We end up with 2 molecules of pyruvate. What's that process called? What's the first step, the first process?
Crop reaction?
That's the second one.
Glycolysis.
There you go. So we know our 2 answers though. Okay. So this part right here, because we started with glucose and we end up with 2 pyruvates, this would be step number 1. That's glycolysis. So you'd have to be able to recognize, oh, this is showing me glycolysis. But then do you see how the pyruvates are getting turned to acetyl coenzyme A? That's the prep reaction. So you're looking at 2 processes of respiration in this diagram. Okay. All right. So that's all I'm going to cover today. Just a couple things for you guys, like immediately exit out. Like I said, I'm going to be getting your test in Power School. So if you're not happy with that, you might jump on in the afternoon, check your grade in Power School. And then if you want to come in and talk about retesting, just jump on my Meet. And like I said, this was kind of lecture 2 stuff and a little bit of lecture 1 stuff. And really, if you get these lectures and your notes filled out, and you have 3 lectures watched by January 4th, you'll be on pace. I am on Tuesday, I'll be going over lecture 3 stuff. So just kind of keep that in mind if you have some time and you want to knock out those lectures and get those notes filled out. Okay. All right. That's it. You guys have a great weekend. You definitely have earned it this week. So work hard, but play hard on the weekends. So, all right, guys, we'll see y'all later.
Hey, Miss Spencer.
Yes.
What time are you going to be back on after Eagle time?
Oh, it is Eagle time. Thank God. I always forget Eagle time. They're probably jumping on now. Like my Meet just stays running the whole time. So 12:15, 12:30. I won't have tests graded until probably 1. So just for those people.
Okay,
that,
I just have to take my test still, so I wasn't sure.
Yeah.
I didn't want to interfere.
No, it doesn't take very long. My Eagle time kids usually just pop in, say hi, and pop out. So.
Okay, cool.
Okay. All right. We'll see you in a little bit.
Could you like show this paper one more time? I didn't get the end of the second reaction thing. So I can just take a picture of it.
Sure.
Okay, thank you. All right, thank you.
You're welcome.
Did you say we only had to have 3 lectures watched by January 4th?
Right. So what I kind of went over is lecture 2 stuff. So when you go back and watch lecture 2, since you've drawn the posters, lecture 2 will make a lot more sense. If you watch it first, like students are like, oh my God, like Miss Spencer, we got nothing out of that lecture. And then when I draw the posters, we're like, oh, this actually makes sense now. So I'm kind of drawing the posters first, and you can watch lecture 2. And then lecture 1 is really just kind of an introduction of some of these ideas that I'm going to talk about, like oxidation reduction. I talk about how enzymes lower activation energy. That's kind of what lecture 1 is about. And then I will be talking about lecture 3 stuff on Tuesday of next week. So just to kind of start knocking them out a little bit.
Okay.
But they're not like all due by Monday or whatever.
Okay.
Hi, Alex. Are you frozen, Alex? Might be frozen.